We are still looking at machines and friction, and under that we have the principle of moments, or the law of the lever. So simply, the law of the lever states that the load force multiplied by the load arm is equal to the to the effort force multiplied by the effort arm. Or you can actually say, it states that the clockwise moments are always equal to anti-clockwise moments. As simple as this. I would like to repeat. The law of the lever states that the load force multiplied by the load arm is equal to the effort force multiplied by the effort arm. Or you can actually say, it states that the clockwise moments are always equal to anti-clockwise moments. That is the law of the lever, or you can say the principle of moments. So here we have an example. We have an example, but we are going to follow this principle here as we are actually trying to calculate. So we are going to follow the principle. The principle is the rule that we have to follow when calculating numbers as far as levers are concerned. So we have an example here whereby you say a man weighs 60 kilogram force, kg, F means kilogram force. He sits 1.5 meters from the pivot or fulcrum of the seesaw. The seesaw is an example of a simple machine. How far from the fulcrum will the boy, whose weight is 30 kilogram force, sit in order to balance the man? So we have two people here. We have the man, of course an adult, and then the boy, who is a child. So the question is asking, how far from the fulcrum will the boy, whose weight is 30 kilogram force, sit in order to balance the man? But remember, this man is heavier than the boy. Therefore, how far can this boy sit in order to balance this man who's heavier than him? Here is the solution. We are going to say solution. Let the man be the effort. Of course, remember last time I told you the effort is the force exerted on a machine to overcome the load or to lift the load. Then, and let the boy be the load. So the man is the effort, and then the boy is the load. The load simply means the force to be overcome. Then let the load be x meters. Let the load be x meters. So we do not know the distance of the man. We don't know the distance of a man from the pivot. So that's why we've said, we do not know the distance of the boy from the pivot. That's why we said, let the load be x, since the boy is the load. As simple as that. So here, look at this diagram. This is a diagram of a seesaw. This side is for the load, and the other side is for the effort. So for us, we are going to have here the boy, and then this side the man. So the boy is weighing 30 kilogram force, and we do not know the meters from the fulcrum. Then the man weighs 60 kilogram force, and the meters of this man from the fulcrum is 1.5 meters. So we are going to follow the rule, the principle of moments, whereby you say load force multiplied by the load arm, the load force, which is 60 kilogram force, multiplied by the load arm, which is 1.5 meters from the fulcrum, is equal. We equate it to the effort force for the boy, which is 30 kilogram force, times the effort arm, of which we do not know. That's why I said let's use x. So we want to find the meters of the boy, or the distance of the boy from the fulcrum. So here we go. We have the 30 kilogram force times the x meters or distance, we do not know, equals to 60 kilogram force times 1.5 meters. Of course, this is the side of the man. We continue by saying 30 times x, you get 30x equals to 30 times 1.5, you get 90. So after that, you have to divide. Of course, this is out of 30, and then the other side also out of 30. So when you divide 30 divided by 30, you get 1. And then 30 divided by 90, you get 3. As simple as that. So the distance here, it is 3 meters. We are not looking for the weight, we are looking for the distance. So we've got the 3. Now, after finding the answer, or after actually getting the answer, don't forget to put the meters, because this is what we are looking for. The moment you just write 3 minus putting the units, definitely we are going to mark you wrong. So you have to put the units. And the units here are the meters. Are we together? Yes, very good, Alex. That's not the only example. We have another example here. So we have example 2. We have example 2. Example 2 says, a boy weighing 60 kilogram force, he sits 2 meters away from the fulcrum or pivot of the seesaw. We've actually used the same example of a simple machine, seesaw, and it's under first class levers. A girl sits on the other side. A girl sits on the other side. The boy sits this way and the girl sits on the other side. At the distance of 3 meters, that's the girl who is seated on the other side, but this girl is seated at the distance of 3 meters from the fulcrum. In order to balance the seesaw, find the weight of the girl. So what do we know here? We know the weight of the boy. We know the distance of the boy from the fulcrum. We do not know the weight of the girl, but we know the distance of the girl from the fulcrum. So this is what we are going to do. We are going to follow the principle of moments, or we are going to follow the law of the levers. We are going to say, let the boy be the effort. This is the boy. And let the girl be the load. This is the girl. So we are going to follow the principle of moment that says that load force multiplied by load arm. LOF means load force, and LOA means load arm, is equal to the effort force times the effort arm. Simple as this. So we are going to say, since we do not know the weight of the girl, we chose to use x. So here we say x times 3 meters, of course the distance of the girl from the fulcrum, is equal to the weight of the boy, which is 60 kilogram force, times his distance from the fulcrum, which is 2 meters. So from there, when you multiply x times 3, you get 3x. And when you multiply 60 times 2, you get 120. So you are going to divide both sides by 3. Here we say 3 divided by 3, you get 1, and 3 divided by 120, you get 40. So here we say our x is 40 kilogram force. Now this is the weight of the girl that we've been looking for. So the question was saying, was actually asking us to look for the weight of the girl, which is 40 kilogram force. Are we there? Yes. So the force, the weight is 40 kilogram force. But if a child happens to write x equals to 40 minus putting the units, we do not mark this child. Much as the 40 is correct, but now what about now the units? 40 what? 40 cows or 40 boys? There we don't mark you. There we do not mark you. So make sure that after finding the weight, put the units. And here the units were kilograms. So we have here example 3. So for this case, we are looking for the distance. We're not looking for the weight, we are going to look for the distance. Example 3 says, a weight of 120 kilograms at a distance of 3 meters, of centimeters from the fulcrum is balanced by a weight of 30 kilograms on the other side. Find the distance from the 30 kilogram weight to the fulcrum. It's a very easy question. I'm going to repeat. A weight of 120 kilograms, grams, at a distance of 3 meters from the fulcrum is balanced by a weight of 30 grams on the other side, of course, of the machine. If not, you can say seesaw, if not a crowbar. Find the distance from the 30 kilogram weight to the fulcrum. So here, we are going to use the same formula or the same principle that says the load force multiplied by the load arm is equal to effort force multiplied by the effort arm. It is here, well stated. So this is actually the formula we are going to use to find the distance. So we are going to say the load force multiplied by the load arm is equal to effort force multiplied by the effort arm. So we are going to say let y be the distance of the load from the pivot. And here we are going to say 30 times y, of course now the distance, is equal to 120 gram force times 3 centimeters. Here we are going to say 30 divided by y, you get 30y. And when you multiply 30 times y, you get 30y. And when you multiply 120 times 3, you get 360. So you divide 30 on both sides by saying 30 divided by 30 equals to 360 divided by 30. When you divide this, when you cancel, you will actually get 1. And then when you divide 360 divided by 3, you get 12. So here, y, what we've been looking for as a distance, equals to 12 centimeters. I told you after finding the answer, do not just leave it naked. What you do, you of course put the required units. And of course here, the units were the centimeters. So the answer is 12 centimeters. As simple as that. We can also add on something small. We have another example here, and I want us to do together. And the example is, we are going to have example 4. It says, Katongole weighs 40 kilogram force or 40 kilograms. He sits at a distance of 10 meters from the fulcrum. Or at times I can call it pivot. For 4 no, weighs 20 kilogram or 20 kilograms and he sits on the other side of the seesaw. And now we are going to say find the distance of Ophono. Find the distance of Ophono from the pivot. That's the question. So you would like to allow me erase these words, and we do the calculations. So we are going to say solution. Following, remember there is a principle that we have to follow in order to find the distance of Ophono from the pivot. And before that, we are going to say, let Ophono be the effort. And Katongole becomes the load. Stop. Or we can even say, let Katongole be the effort and Ophono be the load. Now we are going to say, let Y be the distance of Mr. Ophono. Simple as that. But let's try to follow the other principle that says load force multiplied by the load arm equals to the effort force multiplied by the effort arm. So we are going to say what is the load force of Ophono. The load force of Ophono is actually 20 kilogram force, and his distance from the fulcrum is actually Y. We do not know is what we are looking for. So we chose to use letter Y to represent the meters. And we are going to equate it the effort force, which is actually Katongole's weight. Katongole's weight here is 40 kilogram force times the effort arm, which is actually his distance from the fulcrum. It's 10 meters. So when you multiply 20 times Y, you get 20Y, and you equate it to 40 times 10. What do you get? You shall get 400. You divide both sides by 20, like this. Then when you divide 20 divided by 20, you get 1. And when you divide when you divide 400 by 20, what do you get? You get 20. So you are going to say Y equals to 20 meters. That is our answer. So that's what we've actually got as a distance of Ophono from the fulcrum. So with these learners, I would like to say thank you very much for attending to our lesson of science, and I wish you the best of all. Thank you.